Hello students, welcome to this lecture on statistics. In this lecture, we will solve exercise 13.2, question number 6 to 10 and miscellaneous example, question number 13 to 16. This is disclaimer. We will start by solving NCERT exercise 13.2, specifically questions 6 to 10. Then we will move on to the NCERT miscellaneous examples, questions 13 to 16. So let's get started. Look at question number 6. So in this question, we have to find the mean and standard deviation using shortcut method. So first of all, look at the table. The table shows two rows. In first rows, we have xi, the data values like 60, 61, 62 and so on. And the second row shows fi, the frequency. So first of all, try it yourself and then the solution. Let's solve this question step by step. Now let's see how to find the mean using the shortcut method. The formula we know for mean x bar is x bar equal to a plus h times summation from I equal to 1 to 7 of yi times fi divided by n. Here a is the assumed means, h is the step size between data points, yi is the deviation of each xi from the assumed mean divided by h, and n is the total frequency. For this question, we will choose the assumed mean as 64 since it's in the middle of our data points. The step size h is 1 because each xi increases by 1. Now, let's represent the data in a more detailed tabular form. So, let's look at the table now. So, this is our table. So, in this table, in first column, we have the values of xi. In second column, we have fi. In third column, we have yi. The formula of yi is xi minus a divided by h. And here a is 64. So yi will become xi minus 64 divided by 1. And since h is equal to 1. And in fourth column, we have yi square. And in fifth column, we have product of fi and yi. And in sixth column, we have fi times yi square. Okay. And then bottom of the table, we calculated n equal to summation from I equal to 1 to 9 of fi equal to 100 and summation yi is 220. Okay, and summation from I equal to 1 to 9 if I yi equal to 0 and summation if I yi square is equal to 286. From table, we obtained the value of n is summation from I equal to 1 to 9 of fi equal to 100 and summation from I equal to 1 to 9 of fi times yi equal to 0. Now let's recall the formula for the mean using the shortcut method. So the mean written as x bar is given by x bar equal to a plus sum from I equal to 1 to 9 of fi times yi is divided by n. Here is the assumed mean, yi is the division of each xi from a divided by the class interval h, and now we will use this formula to find mean. In this question, our assumed mean a is 64 and the class interval h is 1. since the xi values increase by 1 each time. So now we will substitute these values into our formula and we will get x bar equal to a plus summation from I equal to 1 to 9 of fi times yi divided by n times h equal to 64 plus 0 divided by 100 times 1. And this is simply equal to 64 plus 0 equal to 64. From the table, we have already calculated two important sums. The sum of fi yi square, it is 286, and the sum of fi times yi equal to 0. Here yi represents the deviation of each xi from the assumed mean divided by the class interval h. Now let's write down the formula for variance using the shortcut method. So variance, which we denote as sigma squared. So sigma squared is given by sigma squared equal to h square is divided by n square times n times sum from I equal to 1 to 9 of fi times yi square minus summation from I equal to 1 to 9 of fi times yi whole square. Let's substitute the values into the formula. So we have h equal to 1, n equal to 100, and sum of fi times yi square is 286, and the sum of fi times yi is equal to 0. So the calculation becomes sigma squared equal to 1 by 100 square times 100 into 286 minus 0. So this step shows how we plug in the numbers from our table into the formula. Now let's simplify the calculation. 100 times 286 is equal to 28,600 and dividing by 100 square, which is 10,000. Okay, so gives us which is 10,000 gives us 2.86. So the variance sigma squared is 2.86, and this is the spread out our data around the mean. So finally, to find the standard deviation, we take the square root of the variance. So sigma squared, square root of sigma squared is basically simply sigma. Okay, so standard deviation sigma equal to square root of 2.86, and it is approximately equal to 1.69. Okay, and the mean which we calculate earlier using the assumed mean method is 64. So our final answers are standard deviation is 1.69 and mean is 64. So I hope this question is clear to all of you. And now let's move to the next question. Now look at question number 7. So in this question, we have to find the mean and variance for the following frequency distributions. Okay, so first of all, very carefully look at the table. So in this table, we have two rows. In first row, we have classes like 0 to 30, 30 to 60, 60 to 90, and so on. Okay, and in second row, we have frequencies. Okay, so first of all, try it yourself and then see solution. Now here we have a table showing class intervals like 0 to 30, 30 to 60, and so on, along with their corresponding frequencies. Our goal is to find the mean and variance for this distribution. Let's talk about how to find the mean itself. Okay, so the formula for the mean in a group data, group frequency distribution is mean equal to a plus h times sum from I equal to 1 to 7 of yi times fi is divided by n. Here n is the assumed mean, h is the class width or step size, yi is the deviation of each class marked from the assumed mean divided by h, and fi is the frequency and n is the total frequency. So this formula will help us simplify calculations especially when the numbers are large. For this question, we will choose assumed mean A as 105. Why? Because it is the midpoint of the central class interval 90 to 120, and the step size H is 30, since each class interval increases by 30. And choosing a central assumed mean makes our calculations easier and helps reduce errors when working with deviations. Now, let's represent the data in tabular form. This is our table. So in this table, we added column midpoint xi, yi equal to xi minus a divided by h, and yi square, fi times yi, and fi times yi square. Okay, and in the bottom of the table, we calculated n equal to summation from I equal to 1 to 7 of fi equal to 30, and summation from I equal to 1 to 7 of fi times yi equal to 2, and summation from I equal to 1 to 7 fi times yi square equal to 76. First, let's see what we have obtained. So from table, we get n equal to summation from I equal to 1 to 7 of fi equal to 30, and summation from I equal to 1 to 7 of fi times yi is 20, and summation from I equal to 1 to 7 of fi times yi square is 2. Okay, and these values are essential for our calculations. So we will use these values to calculate mean. So mean x bar equal to a plus summation from I equal to 1 to 7 of fi times yi times h divided by n. Here a is equal to 105 and h is 30. So these values will be substitute in the formula of mean. X bar equal to a plus summation from I equal to 1 to 7 of fi times yi times h upon n. So after substituting the values into our formula, we get x bar equal to 105 plus 2 times 30 divided by 30. So this step shows how we plug in the sum fi times yi and n and h into the mean formula. Now let's simplify. This is equal to 105 plus 2. Okay, and this is equal to 107. So this is our calculated mean for the given frequency distribution. Next, let's move on to the variance. The formula for variance using the step division method is variance sigma squared equal to h squared divided by n squared times n times summation from I equal to 1 to 7 of fi times yi square minus summation from I equal to 1 to 7 of fi times yi whole square. Okay, here h is the class wide, n is the total frequency, and sum of fi yi square is the sum of frequency times squared deviation. Okay, and the sum of fi times yi is the sum of frequency times deviation. And now we will substitute our values into this formula. So once substituting the numbers, we have variance sigma squared equal to 30 square divided by 30 square times 30 times 76 minus 2 square. So finally, after calculating sigma square, we obtain value of sigma square is 2276. Okay, and this is our final answer for variance. Now let's look at question number 8. So what we have to do in question number 8, first look at that. Okay, so we have to find the mean and variance for the following frequency distributions. So the table shows in first row class like 0 to 10, 10 to 20, 20 to 30 and so on, and second row shows frequencies like 5, 8, 15, 16 and 6. So first of all, try it yourself. How would you approach this question and see solution. So let's see how to solve this question. So now we are going to solving this question step by step. First of all, let's recall the formula of x bar in shortcut formula. Okay, so we know that x bar is the mean given by x bar equal to a plus h times summation from I equal to 1 to 5 yi times fi is divided by n, where fi are the frequencies, xi are data points, and n is the total frequencies and h is the step size. For our calculation, we will choose the assumed mean a as 25 because it's the midpoint of the central class 20 to 30, and h is equal to 10 since step size is 10 here. Now let's organize our data in a more detailed table. So let's look at the table. So here it is our table. So in this table we added the column 3 as midpoint xi and the column 4 as yi, that is xi minus a divided by h, and then column 5 we have yi square, in column 6 we have fi times yi, and in column 7 we have fi times yi square, and in bottom of the table we calculated n equal to summation from I equal to 1 to 5 of fi, this is equal to 50, and summation from I equal to 1 to 5 of fi times yi is equal to 10, and summation from I equal to 1 to 5 of fi times yi square is equal to 68. So we will use these values to calculate mean and variance of the following frequency distribution. From table we have n equal to summation from I equal to 1 to 5 of fi is 50, and summation from I equal to 1 to 5 of fi times yi is equal to 10, and summation from I equal to 1 to 5 of fi times yi square equal to 68. Here a equal to 25, h equal to 10. Now let's calculate the mean using the step deviation method. The formula is mean equal to a plus sum from I equal to 1 to 5 of fi times yi is divided by n times h. And after substituting the values of a equal to 25 and h equal to 10, we get x bar equal to 25 plus 10 times 10 divided by 50. And this is simply equal to 25 plus 2, and this is 27. Now we will find the variance. The formula for variance using step deviation is variance sigma squared equal to h squared divided by n squared times n times summation from I equal to 1 to 5 of fi times yi square minus summation from I equal to 1 to 5 of fi times yi whole square. Let's substitute our values into the formula of variance. So we have variance equal to 10 square divided by 50 square times 50 times 68 minus 10 square. Now let's simplify the expression. We get variance is equal to 1 divided by 25 times 3400 minus 100, which equals 3300 divided by 25. Finally, we calculate the result. So 3300 divided by 25 is equal to 132. So the variance for the frequency distribution is 132. Therefore, variance sigma squared equal to 132. So I hope this question is clear to all of you. So now let's move to the next question. Now let's examine a grouped frequency distribution table showing the heights of children, and it divided into class intervals like 70 to 75, 75 to 80, 80 to 85, and so on, and the number of children in each group. Okay, and notice how the question asks us to find the mean, variance, and standard deviation using the shortcut method. So which is a quicker way to calculate these statistics for group data. So first of all, try it yourself and then see solution. So let's look at solution of this question. So now we are going to solving this question step by step. Let's talk about how to find the mean using the shortcut method. The formula is x bar is equal to a plus h times summation from I equal to 1 to 5 of yi times fi is divided by n, where a is the assumed mean, h is the class interval y, class interval y, and yi is the deviation of each class midpoint from the adjunct mean divided by h, and fi is the frequency and n is the total frequencies. Now let's choose our assumed mean and step size. So we will take a equal to 92.5 since each class interval is 5, and since this value is the midpoint of the data, and h equal to 5 since each class interval is 5 centimeter wide. So we have chosen a equal to 92.5 and h equal to 5. So we need to organize our data in a way that makes calculations easier. So we will represent the data in a tabular form. So this is our data in tabular form. So in this table, we added third column as xi, and fourth column yi, fifth column yi square, sixth column fi times yi, and seventh column fi times yi square. Okay, and here we calculated in bottom summation fi, that is n equal to 60, and summation fi times yi is 6, and summation fi times yi square is 254. From the table, we have some important calculated values. So we have summation from I equal to 1 to 9 if I times yi is equal to 6, n equal to summation from I equal to 1 to 9 of if I is 60, and summation from I equal to 1 to 9 of if I times yi square is equal to 254. And we know mean x bar equal to a plus summation from I equal to 1 to 9 of if I times yi times h divided by n. Here a equal to 92.5, h equal to 5. Now substitute these values into our formula. So x bar equal to 92.5 plus 6 times 5 divided by 60, and this is simply equal to 92.5 plus 0.5, and this is equal to 93. So it implies x bar is 93. So our mean for the below data is 93. Now let's look at the formula for variance using the shortcut method. Variance sigma squared equal to h squared times summation from I equal to 1 to 9 of if I times yi squared divided by n minus summation from I equal to 1 to 9 if I times yi divided by n whole squared. Now let's substitute the values into the variance formula. So sigma squared equal to 5 squared times 254 divided by 60 minus 6 by 60 whole squared. So variance sigma squared equal to 5 square times 60 times 254 minus 6 square divided by 60 square. And after simplifying, we get 25 divided by 3600 times 15204. And this is simply 105.58. So variance sigma squared equal to 105.58. Now standard deviation is square root of variance. So sigma equal to square root of 105.58 is equal to 10.27. So I hope this question is clear to all of you. So now let's move to the next question. Now look at question number 10. So in this question we have the diameters of circles in millimeter drawn in a design are given below. So here you have diameters in class like 33 to 36, 37 to 40 and so on. And here we have number of circles like 15, 17, 21 and so on. And we have to calculate the standard deviation and mean diameter of circles. Okay, and here I'm giving you hint for to solve this question. Okay, so first make the data continuous by making the classes are 32.5 to 36.5, then 36.5 to 40.5, 40.5 to 44.5, 44.5 to 48.5, 48.5 to 52.5, and then proceed like continuous distribution table. Okay, so first of all try it yourself and then see solution. So we will solve this question step by step. So let's see solution. So first of all, let's see. Look at a statistic problem in when we group data here. So we are given the diameters of circles in a design. So grouped into the classes like 33 to 36, 37 to 40 and so on, along with the number of circles in each group. And our goal is to calculate the both the mean diameter and standard deviation. And we know that x bar is the mean given by x bar equal to a plus h times summation from I equal to 1 to 5 of yi times fi divided by n, where fi are the frequencies, xi are data points, and n is total frequencies, and h is the step size. For our data, we will choose the assumed mean a as 42.5, which is the midpoint of the central class 41 to 40. And the step size h is 4, since each class interval covers 4 units. So choosing the central class as the assumed mean makes our calculations easier and helps minimize errors. Now let's represent the data in a table. So the table will help us organize all the values we need for our calculations. So here is the completed table. So let's see here. In first column we have class, in second column we have frequencies fi, in third column we have xi, in fourth column we have yi, that is xi minus a divided by h, and in fifth column we have yi square, in sixth column we have fi times yi, and in seventh column we have fi times yi square, and in bottom we have summation fi is 100 and summation fi times yi is 25 and summation fi times yi square is 199. From table we have n equal to summation from I equal to 1 to 5 of if I is 100 and summation from I equal to 1 to 5 of if I times yi is 25. So these values will be used in our formula for the mean. So mean x bar equal to a plus summation from I equal to 1 to 5 of if I times yi times h divided by n. Here a is equal to 42.5 and h equal to 4. Let's substitute the values into our formula. So we get x bar equal to 42.5 plus 25 times 4 divided by 100. This is equal to 43.5. Now let's move on to the variance, which is a measure of how spread out the diameters are. The formula for variance using the shortcut method is variance sigma squared equal to h squared divided by n squared times n times summation from I equal to 1 to 5 of fi times yi square minus summation from I equal to 1 to 5 of fi times yi whole squared. Here summation from I equal to 1 to 5 of fi times yi square is 199, and summation from I equal to 1 to 5 of fi times yi is 25, h equal to 4 and n equal to 100. So now we will use these values to find variance sigma squared. So after substituting these values into the formula, we get variance sigma squared equal to 16 by 10,000 times 100 times 199 minus 25 squared. Sigma squared is equal to 16 by 10,000 times 19,900 minus 625. And after simplifying, we get sigma squared equal to 16 times 19,275 divided by 10,000. And we have calculated the variance as 30.84. Now, to find the standard deviation, we take the square root of variance. So, sigma equals the square root of 30.84 equal to 5.55. Hence, standard deviation sigma equal to 5.55 and mean x bar equal to 43.5. I hope this question is clear to all of you. Now, we will solve miscellaneous example question number 13. So here in this question, we have the variance of 20 observations is 5. If each observation is multiplied by 2, then find the new variance of the resulting observations. So first of all, try it yourself and then see solution. So the question asks, if the variance of 20 observations is 5, what happens to the variance if each observation is multiplied by 2? So this is a classic example of how variance changes when we scale data. So we will solve this step by step. Let the observations be x1, x2 up to x20 and x bar be their mean. Given that variance is 5 and n equal to 20. Now recall the formula for variance. The variance written as sigma squared equals 1 divided by n times summation from I equal to 1 to 20 of xi minus x bar whole square. That is 5 equal to 1 divided by 20 times summation from I equal to 1 to 20 of xi minus x bar whole square. Here we substitute the variance sigma squared equal to 5 and n equal to 20. Now let's solve for the sum of square divisions. So multiplying both sides by 20 gives us summation from I equal to 1 to 20 of xi minus x bar whole square equal to 100. If each observation is multiplied by 2 and the new resulting observations are yi, then yi is equal to 2 times xi and it implies xi is half of yi. Therefore, y bar is equal to summation from I equal to 1 to 20 yi divided by n. So it implies y bar equal to 1 by 20 of summation from I equal to 1 to 20 of 2xi, and this is equal to 2 times 1 by 20 summation from I equal to 1 to 20 of xi. So y bar equal to 2 times x bar, or x bar equal to half of y bar. On substituting the values of xi and x bar in summation from I equal to 1 to 20 of xi minus x bar whole squared equal to 100, we get summation from I equal to 1 to 20 of half of yi minus half of y bar whole squared equal to 100. That is summation from I equal to 1 to 20 of yi minus y bar whole squared equal to 400. So now the new variance sigma 1 square equal to 1 divided by 20 times summation from I equal to 1 to 20 of yi minus y bar whole squared. It implies sigma 1 squared equal to 1 divided by 20 times 400, and this is 20. Thus the variance of new observation is 20, that is 2 square times 5. So note, if each observation is multiplied by a constant k, the variance of the resulting observation becomes k squared times the original variance. So note this, note this point. This is very important point to find the variance of scale observations. Now let's look at question number 14 of miscellaneous example. So the question gives us the mean of 5 observations is 4.4 and the variance is 8.24. If 3 of the observations are 1, 2 and 6, then we have to find the other 2 numbers. Okay, so first of all try it yourself and then see solution. So let's solve this question step by step. So let the other 2 observations be x and y. So our series is 1, 2, 6, x, y. Now mean x bar is the sum of all observations divided by the number of observations. So x bar is given to us 4.4. So 4.4 equal to 1 plus 2 plus x plus y divided by 5. Let's solve for x plus y. So multiplying both sides by 5 gives us 22 equal to 9 plus x plus y. Therefore, x plus y equal to 13. So note this equation. It will help us to find x and y. So for that we have to get another equation. And we know the variance equal to 1 divided by n times the sum of squared differences of the sum of the squared differences between each observation and the mean. Okay, that is 1 divided by n times summation from I equal to 1 to n of xi minus x bar whole squared. And we have given that variance is equal to 8.24. Therefore, variance 8.24 equal to 1 divided by n summation from I equal to 1 to 5 of xi minus x bar whole square. That is 8.24 equal to 1 divided by 5 times 4.4 minus 1 whole square plus 4.4 minus 2 whole square plus 4.4 minus 6 whole square plus 4.4 minus x whole square plus 4.4 minus y whole square. It implies 8.24 equal to 1 divided by 5 times 3.4 whole square plus 2.4 whole square plus 1.6 whole square plus x square plus y square minus 2 times 4.4 times x plus y plus 2 times 4.4 whole square. So simplify this and we get 41.20 equal to 11.56 plus 5.76 plus 2.56 plus x square plus y square minus 8.8 times 13 plus 38.72. Therefore, x square plus y square is equal to 97. So we have x plus y is 13. On squaring both sides, we get x square plus y square plus 2xy equal to 169. From x square plus y square is equal to 97 and x square plus y square plus 2xy equal to 169. So we have 97 plus 2 times xy equal to 169. So this simplifies to 2xy equal to 72. So it implies 2xy equal to 72, which means xy is equal to 36. So subtracting 2xy equal to 72 from x square plus y square equal to 97, we get x square plus y square minus 2xy is the same as x minus y whole squared. So we have x minus y whole squared equal to 25. So it implies x minus y equal to plus minus 5. This means that the difference between x and y could be either 5 or minus 5. And we have x plus y is equal to 13. So from x plus y is 13 and x minus y equal to plus minus 5, we get x equal to 9, y equal to 4 when x minus y equal to 5, and x equal to 4 and y equal to 9 when x minus y equal to minus 5. Thus the remaining observations are 4 and 9. I hope this question is clear to all of you. So now let's move to the next one. Now let's examine what happens to the variance when we add a constant value a to every observation in a dataset. So the question asks us to show that each value x1, x2 up to xn is increased by the same amount a, then the variance does not change. Okay. So let's see how to solve this. So let x bar be the mean of x1, x2 up to xn, then the variance is given by sigma 1 squared equal to 1 divided by n times summation from I equal to 1 to n of xi minus x bar whole squared. If a is added to each observation, then the new observations will look like yi equal to xi plus a for each I. Now we define the mean of these new observations. So we will call this new mean y bar. So it's important to see how adding a to every value affects the mean. Now let's calculate the new mean. The formula is y bar equal to 1 divided by n summation from I equal to 1 to n of yi equal to 1 by n summation from I equal to 1 to n xi plus a. This is equal to 1 divided by n of summation from I equal to 1 to n of xi plus summation from I equal to 1 to n of a. So this is equal to 1 divided by n times summation from I equal to 1 to n xi plus n times a divided by n. This is equal to x bar plus a. That is the new mean y bar equal to x bar plus a. Thus, the variance of the new observations, since y bar is x bar plus a, and each new observation y is just the original xi plus a. So y bar equal to x bar plus a and yi equal to xi plus a. So let's write out the formula for variance of the new observations. The variance is sigma 2 squared equal to 1 divided by n times summation from I equal to 1 to n of yi minus y bar whole squared. This is equal to 1 divided by n times summation from I equal to 1 to n of xi plus a minus x bar minus a whole squared. And this is simply equal to 1 divided by n summation from I equal to 1 to n of xi minus x bar whole squared. This is equal to sigma 1 square. Thus, we conclude now the variance of the new observations is same as the original observation. I hope this question is clear to all of you. So now let's move to the next question. Now look at miscellaneous example 16. Okay. So the mean and standard deviation of 100 observations were calculated as 40 and 5.1 respectively by a student who took by mistake 50 instead of 40 for one observation. So what are the correct mean and standard deviation? So first of all, try it yourself and then see solution. So given that the number of observations n equal to 100 and incorrect mean x bar is 40 and incorrect standard deviation sigma is 5.1, and we will need to correct both the mean and standard deviation as we proceed. So we know that the formula for the mean x bar is equal to 1 divided by n times summation from I equal to 1 to n of xi. That is by substituting the values into the formula, 40 equal to 1 divided by 100 times summation from I equal to 1 to 100 of xi, or summation from I equal to 1 to 100 of xi is 4000. So the incorrect sum of all observations is 4000. So this sum includes the mistaken value of 50 instead of the correct value of 40. Thus the correct sum of observations is incorrect sum minus 50 plus 40. So let's do the calculation. So this is equal to 4000 minus 50 plus 40 is equal to 3990. So the correct sum of all observations is 3990. Hence, correct mean is correct sum divided by 100. This is equal to 3990 divided by 100, and this is equal to 39.9. Also, standard deviation sigma equal to square root of 1 divided by n times summation from I equal to 1 to n of xi squared minus 1 divided by n squared of summation from I equal to 1 to n of xi whole squared. This is equal to square root of 1 divided by n summation from I equal to 1 to n xi square minus x bar whole squared. Since incorrect standard deviation sigma is 5.1, so therefore 5.1 equal to square root of 1 by 100 times incorrect summation from I equal to 1 to n xi square minus 40 whole square. Now on squaring both sides, we have 26.01 equal to 1 divided by 100 times incorrect sum from I equal to 1 to n xi square minus 1600. The incorrect sum from I equal to 1 to n xi square equal to 100 times 26.01 plus 1600. The incorrect sum from I equal to 1 to n xi squared equal to 162601. Since student accidentally used 50 instead of 40 for one observation, this means both the sum of the observations and the sum of the square of the observation are incorrect. So we will need to correct both to find the right answer. So therefore correct summation from I equal to 1 to n xi square equal to incorrect sum I equal to 1 to n xi square minus 50 square plus 40 square. This is equal to 16162601 minus 2500 plus 1600. This is equal to 161701. So therefore correct standard deviation is equal to square root of correct summation from I equal to 1 to n xi squared divided by n minus correct mean whole square, where correct mean is 39.9 and correct summation from I equal to 1 to n xi squared equal to 161701. So now let's do the calculation step by step. So correct standard deviation equal to square root of 161701 divided by 100 minus 39.9 whole square. This is equal to square root of 1617.01 minus 1592.01. This is simply equal to square root of 25 equal to 5. So this shows the correct standard deviation is 5. So correct standard deviation is 5. So I hope this question is clear to all of you and you are getting my point. So that's all for today's lecture and thank you very much to all of you.